Okay, welcome, and we're going to again just kind of continue on from where we were and finish this chapter here. So, just like before, again, if you do have questions, feel free to ask them, and we'll get those answered for you. And we'll do a few more examples here, and then finish the chapter talking about a few other things. And then we should be done with this one. All right, so we are looking at sort of colligative properties. We're looking at freezing point depression, uh, boiling point elevation. And again, these are all properties like freezing point, boiling point that are affected by, the particles that are in the solution. So again, these particles that get in the solution basically get in the way of the natural sort of process of freezing or boiling, and they essentially will disrupt the normal temperature where these things occur. So the previous example, we did freezing point depression, where we figured out that the solution would actually freeze at minus 3.2 degrees versus 0 degrees Celsius if it was just water by itself. Here, we could also use the freezing point depression to figure out some other aspects of a solution. So let's take a look at this one here and see what we're looking for. We want to calculate the molar mass of a compound. If the solution is 12 grams of it is dissolved in 80 grams of water, and that solution freezes at minus 1.94 degrees Celsius. So this again is going to be our solute here. Larger part here is going to be our solvent. And again, here that's important because our solvent is water. We are actually looking for the molar mass. And if you just think about the units of molar mass, that is grams per mole. It's basically the units that we associate with molar mass. And really, right off the bat, in terms of this, we know the compound, we took 12 grams of it. And that actually is the top part of what we need. So we actually have half of what we need sort of given to us in the actual problem. So what we need to do is figure out the moles part of it. And the moles part of it is going to come from really the freezing point information. And that's really the other information that we have, which is the freezing point information. And in this particular case, it tells us that this solution will actually freeze at minus 1.94 degrees Celsius. So we can actually use the freezing point equation here to help us figure out the moles part. So let's see how we could do that. We know that the delta TF is equal to M times KF. Now, in this particular case, again, we're going to look up the freezing point constant. And again, this is going to be for water, which is our solvent. So when you're using these formulas, you want to make sure that you look up the solvent. Again, you're not going to be able to find the actual solution in those tables. It is just based on the solvent. Now, this is also where what we saw earlier is important, that the change in freezing point temperature is the temperature of the solvent minus the temperature of the solution. And why that's important is the number that they gave us is the temperature of the solution. And it happens to be negative. So when we actually put it into this equation to find the change in freezing point, our solvent, which is water, normally freezes at 0 degrees Celsius, minus this solution, which will freeze at minus 1.94 degrees Celsius, which means actually our change in freezing point temperature is 1.94 degrees Celsius, and it is positive. So that's how we actually do get rid of the negative number there, is by using that little equation. Because again, the minus 1.94 is technically not the change in freezing point temperature, but it is actually where the temperature of that solution will freeze. So now we have everything here in this equation except for molality. So that would make sense to solve for molality. So the molality would be the change in the freezing point temperature divided by the Kf. And again, here, this is why it's important that we got it to a positive number divided by our constant, which we would find on the table. The degrees Celsius will cancel, and that's going to leave us with molality. And that's going to be 1.94 divided by 1.86. That is going to give us 1.04. For the molality. Now you may say to yourself, M is moles, and it's not. Yes, again, that is molality. That is not the moles of this compound. So we're almost to the moles part, because again, if you remember, the molality is the moles of the solute divided by the kilograms of the solvent. So what we just calculated is actually, the molality. We are looking for the moles of the solution or the solute here. So we do need the kilograms of solvent. And we can find that here in the problem. We have 80 grams of water, which is our solvent. So 80 grams of water, which is our solvent. But remember that we don't need it in grams. We do need it in kilograms here. So we're going to have to convert it. So there are 1,000 grams in a kilogram. And that's going to give us 0.08 kilograms for our solvent. Now we do have that number. That means the moles of our solute, which is what we're looking for, will equal the kilograms of solvent times the molality. So that's going to give us 0.080 kilograms times our molality that we calculated, 1.04 moles per kilogram. That's essentially what that is, right? 1.04 moles per kilogram. Kilograms will cancel, and we will end up with 0.0834 moles. And now we actually do have moles, which now that actually is what we're looking for up here, that number. So now we have the grams and we have the moles. We could actually get the molar mass by really just plugging those numbers in. So we had 12 grams of the compound, and we had 0.0834 moles. And if we divide that we end up with about 144 grams per mole as the molar mass of this compound. So you can see here, we could actually use the freezing point information and the molality that we calculated to actually figure out the moles of this solute or compound. And we have the grams. So in addition to something like freezing point, the temperature at which it freezes, we could use this information to figure out the molar mass of a particular compound. Any questions on any part of that calculation there? Okay. So I think it's the one we just did. We'll just kind of give you a nicer, neater look at it, I suppose. All right, so why don't you try this one here and see what you come up with. So we want to know how many grams of ethylene glycol must be added to 1 kilogram of water to give a solution that boils at 105 degrees Celsius. So some of the information that you need is right there on the screen. So why don't you take a couple of minutes and see what you come up with in this case, and then we'll talk about it.